Welcome to the Explainer. Today, we're going to talk about something really powerful that's changing how we all manage our computers. It's called the declarative approach. The idea here is to build systems that are super stable, totally reproducible, and, it might just be the future of computing.
All right, let's dive right in. And we're going to start with a feeling. A feeling I bet is very familiar to a lot of you out there.
I mean, you know that feeling, right? Your whole system feels like this delicate house of cards. You install one little piece of software, and boom, something else breaks. Or you run a system update, and suddenly, your audio doesn't work. And don't even get me started on setting up a new computer. It's a total nightmare. You're manually installing packages, tweaking config files for hours on end, just hoping you remember every single tiny step you took on your last machine. It's just so fragile. It's all manual, and honestly, it's just asking for errors.
So what if you could just escape that whole cycle? Just imagine for a second, describing your entire system. I mean, every app, every setting, every single service in one single file. A blueprint. And then you just run one command. And the system builds itself, perfectly, exactly matching that blueprint every single time. That's the beautiful, elegant promise of a declarative OS.
Okay, so how does this whole declarative dream actually get built? Well, it really starts with understanding what we mean by declarative in this context. It's a pretty simple shift in thinking, but honestly, it's a profound one.
So the core idea is pretty simple. Instead of telling the computer how to do something, step by step by step, you just declare what you want the final result to be. You're not saying, okay, computer, first install this, then run that command, then go edit this file. Nope. You just say, hey, I want my system to have this web browser, this code editor, and this specific network setting. And then the operating system itself figures out all the steps to make that happen. It's all reliable, and it's all automatic.
And look, this isn't just some theory. This is real. With systems like Guix or NixOS, your entire OS configuration literally lives in one single human-readable text file. For Guix, you'll find it in config.scm. For NixOS, it's in configuration.nix. You just go in, edit that one file, you run a single command, and your whole system updates to that new configuration. It's really that powerful.
So who are the big players here? Who's really pushing this whole declarative approach to its limits? Well, let's meet the two main champions in this space, Guix System and NixOS.
Now, they both share that same core idea, but they've got some really important differences. First up, you've got Guix. It uses the Scheme programming language, and this is key. It's deeply committed to the ideals of free software. It even uses the Linux Libre kernel, which means zero proprietary binary blobs. NixOS, on the other hand, it uses its own custom language, the Nix language, and takes a more, let's say, pragmatic approach. It's all about flexibility and having this huge collection of packages, even if some of them aren't free. And that's exactly why it's become so popular with developers and in the whole DevOps world.
So here's the bottom line, right? Guix is really for the purist. It's trying to build this complete self-contained world of 100% free software. Nixos, that's for the pragmatist. It gives you incredible power and flexibility for building complex dev environments and servers, and it's willing to make some practical trade-offs to get you there.
But, this whole thing, it isn't just an all-or-nothing choice. It's not like you're in or you're out. As we're about to see, declarative is actually more of a spectrum. You've got different tools and systems that are adopting parts of this philosophy.
And you can see that spectrum laid out perfectly right here. On one end, you've got the fully declarative champs we just talked about, Guix and NixOS. Then way over on the other end, you've got your traditional manual systems. Think Arch Linux or a standard Ubuntu install. But right there in the middle, that's where it gets interesting. You had this whole quasi-declarative category, with tech that's clearly inspired by these ideas, but maybe doesn't go all the way. So let's quickly unpack some of these related ideas, because it can get a little confusing. First, you've got immutable distros, like Fedora Silverblue. They give you a ton of stability by making the core system read-only, but they're not driven by that single master config file like a NixOS is. Then you have your configuration management tools. Think Ansible or Terraform. They're definitely declarative, but they're focused on managing servers, not building the core OS from scratch. And finally, there are these really cool tools like Home Manager, which lets you kind of dip your toes in the water. You can use it to declaratively manage just your stuff, your personal settings and apps on top of whatever Linux system you're already using.
Okay, so that's a lot to take in. I get it.
So the big question is, where does that leave you? How do you actually get your hands dirty with this stuff? Well, let's break it down into a clear, actionable guide. So there are basically 3 great ways to get started, and it really just depends on your goals. First, if you're a pragmatist and you want that huge community and massive package library, NixOS is your answer. It's the clear choice. Second, if you're more of a purist and your #1 priority is a 100% free software environment, then Gwix System is the path for you. And finally, for the cautious choice, if you're intrigued by all this but maybe not quite ready to switch your whole OS, you can try Home Manager. You can install it on your current system, like today, and start playing around.
And that brings us to our final thought. You know, this ability to perfectly reproduce an entire complex system from just a single blueprint, it's a revolutionary idea. It really is. It promises an end to all that stuff we hate. Configuration drift, fragile updates, and that classic, well, it works on my machine problem. So the question we want to leave you with is this. Are we looking at the future? Is this how all complex software systems, from our own laptops to massive server farms, are going to be managed? The declarative champions, well, they're betting on it.